Hello, my name is Yunus. I'm a mathematician, and today I'm going to do with you linear interpolation. I'm going to explain to you what is it, when do we use it, and why it works. In the end, I'm going to do an easy A-level maths stats question using linear interpolation to find out the median. Okay, so the topic that I'm doing again is linear interpolation. What is linear interpolation? It is a method of curve fitting using linear polynomials to uh, construct new data within a range of discrete data given. Okay, so with other words, uh, if I'm going to do it in here, if for example we have, let's say we have here x y axis. I do apologize for the quality of the video. I'm just recording with one hand and writing with the other hand. Let's say we have 2 points here and here. Let's call this one A and this one B. This is XA, XB, and this is YA and YB. Now if we connect those 2 points, if we connect them with a straight line, we are going to have a linear interpolant. This is line is called linear interpolant. Inter means in between, okay, between A and B. We connected those 2 points and this is called linear interpolant. Now what does linear interpolation give us? If for example we get a point somewhere here, it doesn't need to be in the middle, but let's say we have a point in here which is, we call it C. If we were given xc, we use the linear interpolant equation to find out the y coordinate, which is yc. Okay, so this is we going to use the equation of the slope of the line. Just want to add something to say. For example, sometimes you hear linear extrapolation. Extrapolation if the point is outside, it's not in between the A and B. For example, the point is going to be in here. So let's say it's C in here or D or anything. Then we are going to use linear extrapolation. Okay, that is just quick. In the end, I'm going to show you one example in statistics that we use linear interpolation. So to do that, we said we are going to use the equation of the slope. Okay, the equation of the slope, we can start by writing, we can say yc minus ya. If we using those 3 points, let's say those 3 points, over xc minus xa is going to be equal to yb minus ya over xb minus xa. Okay, and then from here we said we want to find out what is yc. Okay, so from this equation I can take yc out. So yc is equal, I need to multiply this expression with that and take the ya to the other side. So I will have ya plus xc minus xa times with yb minus ya over xb minus xa. Okay, that is the equation that we are going to use. But I just want to say, like, if we have a exam question, we don't need to write the equation and then do it step by step. I'm going to show you later how to do it like quicker. Okay, but for now I'm going to use the formula or this, and then I'm going to use something else. So let's say we have this table that is a question, stats question, A-level stats question. Is in the start. It's in when we're talking about measures of location and spread, and one of the measures of location is the median, which is a central tendency measure, one of the central tendency measures. Let's say we have here weights in kilogram, and let's say we have the frequencies. Okay, so let's take just 3. Okay, so let's take so between 1 and 1.5 kilogram weight and 3. between, so let's add this one here, between 3 kilogram and 4, and between 4 and 6. This frequency here is 10, 8 for example. Let's say this one is 14. So one mistake that many students might do in A level, they just always take, oh, we have 3 intervals, class intervals. We take the middle one is where the median is. Sometimes it works, sometimes it doesn't, but that's not the correct method. So it depends on the frequencies. Okay, so I'd like to add in here in the side, I'd add cumulative frequency. Cumulative frequency, that means what frequency accumulated till the end of this point. So here we have 10, then we add 10 to 8, we get 18. 18 to 4 added to 14 is 32. Okay, so now we have this table. Sometimes they don't give you the cumulative frequency, sometimes they do. So we say we want to find out the median. The question is find the median. Okay, the question is find the median. Okay, so to find the median, first thing we need to find the median class interval. The median class interval is one of those, this or this or this. Okay, how do we find it? We take the cumulative frequency, this one, so the total. Please do not add 10 to 18 to 32, because we'll get something that's we're not using at all. You can add 10 to 8 and 14, which you will get 32 as well. So we do 32 divided by 2, which is 16. What does 16 give us? The position of the median. Position of the median. Okay, the position of the median. Now we go back to the cumulative frequency. We see, so up till here, the class interval, we have up till here we have 10. So the 16 is not in this class interval. If we move to the next interval, we have till 18. So between 10 and 18. So the median or the position 16 is going to be somewhere in this class interval. So we are going to be we know that the median is going to be in this class interval. Okay, from here we come, I like to draw a line in here that is not a fraction line, it's just a line, and I like to put some values on the line above and below the line. So I'm looking for the median. I'm writing median here. It works not just for the median, for the other interquartile ranges and anything else, but for now I'm looking for the median. Median, the position of the median we said is 16. Okay, here 16, the position. So the median that I'm looking for is going to be a weight, so it's in kilogram, which makes sense. So in the bottom I'm going to write the values that have units in kilograms. In the top we have the what you call it, we have the position and the frequencies. Okay, so we have here the cumulative frequency up to or just before cumulative frequency just before the class interval that we are interested about, and here the cumulative frequency at the end of the interval, okay, that we are looking for. And here it's going to be, here is going to be the value at the start of the interval, the value at the end of the interval. We're looking at the values here. We have 3 and 4. So in here we have 3 kilograms and here 4 kilograms. Okay, and it will make sense. So the median is going to be somewhere between 3 kilograms and 4 kilograms. Okay, somewhere. It's not always the middle, which is 3.5, because we have different frequencies. It's not spread with the same proportion. Okay, so here we have the cumulative frequency just before. The cumulative frequency just before the class interval is 10, and at the end is 18. I'm going to put the values here, 10 and 18. Okay, so that, after drawing this, I can use the formula, or I can, so the YC that I'm looking for is the median. So the YC is the value of the median. So I can say those on top is the X values, on the bottom is the Y values. okay, x values on the top of the line, y values in the bottom. Later I'm going to show you just a quick thing that we can do and we get the answer within like in 2 lines or 1.5 line. But for now I'm going to use the formula. Let's call this one point A, this one C that I'm looking for, and this is point B. Okay, A, C, B. So we can tell that this is XA, YA, XC, YC, XB, YB. Okay, using the same formula, I'm just going to do it step by step. So YC, what is YC? Is the median. So the median or YC is equal to YA. YA, that is Y of A is 3 kilograms. So I'm writing 3 kilograms plus the formula tells us XC minus XA, XC minus XA, XC minus XA, which is 16 minus 10, okay, times YB minus YA, YB minus YA, YB is 4 kilograms, 4 minus YA, which is 3 kilograms, over XB minus XA. XB is 18 minus XA is 10, so minus 10. So this together is 3 kilograms plus 6 minus is 6 times 1 over 8. So 6 times 1 over 8 is 0.75. So this is going to be 3,75 kilograms. That is the median. Okay, that's the question answered using the formula, the equation of the slope. Okay, that's one way how we do it. And in the exam you don't have much time to write the formula and then to think about it, so we can just do something quickly. So if you think about the proportion, so if you split, you say that difference divided by that difference is the same as that difference divided by that difference. Okay, or you can take any other two. So you can start with that difference divided by that difference is the same as that difference divided by that difference. Okay, using that we can find out the same value of the median. So I'm going to do it here quickly. So we said that difference, so which is the difference between 10 and 16, which is 6, over the big difference, which is 10 to 18, which is 8. So I'm going to write 6 over 8 is equal to, we have a fraction as well, so is the same as the difference between 3 and the median. I'm going to call the median M, capital M. So M minus 3 over 4 minus 3. Okay, so M minus 3 over 4 minus 3 is 1. Okay, and from here I can say that M minus 3 is equal 1 times 6 over 8, or 3 over 4. So I just leave it as so I change it to 3 over 4. So 6 over 8 is 3 over 4 simplified, and from here I can tell that M is equal to 3 add 3 over 4. 3 add 3 over 4 is 3,75 kilograms. Okay, so that's the way how we do it. So if, for example, you get a question in stats A level saying to you to find, giving you a table, for example, and tell you to find the median or the interquartile ranges, anything like that. If we want to use the linear interpolation, that's the way how we do it. Usually we just draw a line. Some teachers don't do that. I like to do it just to separate between the values on top and the values in the bottom. I'm writing for the median or whatever it is we're looking for in the bottom, the position of it on top, and then the other values you can tell here, the cumulative frequency just before the interval, at the end of the interval, and the value at the start of the interval, and the value in the end. And we can use any differences. So as I said before, you can start with that difference divided by that difference is the same as that difference divided by that. But because here, if you use that, what I just said, we will have the unknown twice. So it's better if you use something like one time you use the unknown and one time you use the two values that we know. Okay. Yes, if you want to use the formula for the slope of the line, you can use it, but you don't have to. You are going to use it anyway, just indirectly. I want to tell you why do we do this, and they don't draw you a line or so. In statistics, usually when you plot the points, the values, after taking any statistics, anything, you get some point, like 1 point here, for example, 1 point here. You don't get one straight line, like a very good straight line like that. Okay, and they tell us, let's say they want to find the value, the y value of a point that is in here. Okay, that's what when we do the line of best fit. So obviously I'm using just my hand. So the line of best fit, taking 2 points, let's say we have a point in here and a point in here. That's when we call this one A and this is B, and this is the point that is going to be C, and then we want to find that. So that's when we use linear interpolation. If the point that they want is somewhere outside, that's going to be linear extrapolation. Okay, thank you for watching. Please share it with your math student friends, and if you have any questions, just write a comment below. Any comments, write it please, and subscribe please. Share this video with your friends and with other maths groups or anything like that. Thank you very much. Again, if you want, I'm putting some stats A-level maths lessons on my YouTube. After finishing with the stats, I'm going to move to pure maths, then mechanics, further maths as well, but step by step. Okay, thank you very much. You were with Herr Laaouini or Mr. Laaouini. Thank you. Bye bye.